guys. Oh, Zach, you made it. Good. We were just praying for you. We were supposed to have a forever quiz at the very beginning of class today. What would the forever quiz at the very beginning of class today have been about? Yeah, but what forever cards are there this chapter? Let's talk about that. We have a test tomorrow.
There's the washer and disc method.
There's washers is the most recent. Disc is the one right before that. Area between a curve, and then cross-sectional slices volume. There's four cards. Area, volume by cross-sections, volume by discs, and volume by washers. So therefore, instead of having the forever quiz be at the beginning of class, we're going to have the forever quiz be at the end of class. If you guys want to grab out your forevers or just be studying the formulas in your notes, we're going to be using them all day today, right? Our chapter test is tomorrow. As always, you guys can come in at 7:45, start at 7:50. If you don't come in early, there's no reason that I will give you any extra time. It's your responsibility. But there will be a forever quiz today at the end of class on the formulas that we'll be using all class long. The test review, we will be going over questions that you have on the test review. I think there were only 5 questions, right? I think there were 5 questions. So hopefully you had time to look at them all, and then you can ask me any questions that you have in just a second. I'm getting out your book. But at the beginning of class, here's what you missed, Zach. They were working on this FRQ. Let me go ahead and just take away all temptation for you, okay? There we go. They were looking at this review right here. Or I should say this FRQ to review. So first of all, I have it in my calculator because it is a calculator problem, yeah? Okay. We did have to zoom out a little bit in order to see exactly what was going on. But then, kiddos, what does part A ask us for? We're supposed to be finding the area. So when we're finding the area, when you guys were looking at it, what did you think? Top minus bottom or right minus left?
Top minus bottom.
I thought top minus bottom too, because first of all, wouldn't these little x values be great like a's and b's, right?
Yeah.
Wherever these are. And then if you draw a sliver, a top minus bottom would be very nice because on bottom you would have your y equals 2, and on top you would have your 20 over 1 plus x squared is y, right? So how did you guys set up the integral?
I think it was -3 to 3, the intersections.
Was it -3 to 3 perfectly?
Yeah.
Oh, well that's really nice. Don't even need to like do the whole stowing of the values, etc. So -3 to 3 of? Good. Top minus bottom. Good.
Yes.
Yeah. If you don't write this, I can take a point up. I should because the AP put your entire expression because they're going to give a point on the integral expression. I can almost guarantee it. Okay, so
You don't need your pi.
why not pi? It's just area. So if you're looking at this forever card or these formulas in your notes to be studying, area is either top minus bottom in terms of x, so x1 to x2 dx, or what's the other way area can go?
Left to right. I mean right to
Right minus left from y1 to y2 dy, right? Okay, those are the 2 different area formulas. When you guys plug this into your calculator, wait, plug it into your calculator. Yeah, it's a calculator problem. Don't you dare solve by hand. What was the nice little decimal that you got out? 18 point? 18 even? 18,000. Yeah. I'm asking for the answer to this integral after you plug it into your calculator.
37.962.
Okay, I heard it said in tandem twice, so we're okay? Okay. This is all the work that you should show for this problem. Any questions? Top minus bottom, dx, plug in the integral, done. Okay, so what was letter B asking? All right. The volume but rotated, that's key, right? The volume but rotated. My calculator can be kind of cool sometimes. So we have this region, right? Where is it supposed to be rotating about? Okay, that'd be this guy down here, right? Okay, why am I showing the axis of revolution? What did I say yesterday? What should we do? Always start at, well, sure, we should start probably there. Sean's reminding us dx or dy. Guys, which one is it? Dx, good. So now v is going to equal, it's a pi, David, because rotated, so we have a circle. We need our integral to be in terms of dx. And I should be, wait a minute, hold on. Is this just r squared, or is it big R squared minus little r squared? You see that empty space? I do. So then we know it's going to be big R squared minus little r squared. So then we need to go ahead and find that. Do we know our bounds? Oh, yeah. What were our bounds? Good. -3 to 3. Okay. So let's go over here. We always do. Yeah. Good. Whatever. Go all the way down. Now, some of you guys are actually writing this out, and a couple kids this morning were like, I think it's helpful. So let's just talk about it. Who's on top? Who's on top? Good. 20 over 1 plus x squared. Who's on bottom?
2.
Who's on bottom? 0. The axis. The axis is y equals 0. 2 is a part of it, but we have to go from the axis all the way out. So it would be top curve minus bottom is 0. Okay? But now when we go to my little r, now we're going to use the 2, because little r says start from the axis and go to the edge of the white space. So who's on top of the white space? 2. Good, 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 good. You see it? Now let's just plug it in. So we have v is equal to pi -3 to 3 of squared. If you want, you can write the -0. I'm illustration because it was top minus bottom for big R minus top minus bottom for little r. Yes, you could have simplified it. Go ahead.
If you just like said that 20 over 1 plus x squared is like f of x, to simplify your, would you have to, I guess you'd have to solve that numerically, but to save time writing it out, could
Just write f of x?
Yeah. And
You should be fine, but just plug it in your calculator. F of x equals, I mean, they say f of x. Well, you would need to say something like f, yeah. Yeah. The problem is what you write, there's an original given, and then it states a question with a big old space to answer for A, a line. Then it states a question with a big old space. So whatever you wrote up here, just be careful. Make sure the work is in those boxes. Because if you're just like drawing all over the question, they'll probably ignore that. But whatever you put in the actual boxes themselves, they'll pay attention to. Who threw it in and had the answer for me?
That's the 1,871.190.
Now I have to ask you a question. Did you multiply by pi? Okay. If you didn't multiply by pi, what would you need to write next to it to be right? Okay, so you could have solved and then written the pi and boxed it, or you need to make sure that pi is involved. Okay, so we all matched up. We're good? Okay, so 6.1 was letter A. 6.2b is letter B. What's 6.2a? Letter C. Letter C. Now, I'm going to go ahead and draw this one by hand just for sake of argument. I'm going to make it a little bit slanty just because, not that you guys have to draw this picture in any way, shape, or form, but I just need to make sure that you understand why I'm about to do what I'm about to do, or why hopefully you did what you did. So we have, you guys said -3 and 3, right? Okay, we have our two functions, and then we have this region in between. What does this problem tell me? Cross sections perpendicular to the x-axis and semicircles. We need all three of those pieces of information. Okay? Because it's perpendicular to the x-axis, my sliver needs to go perpendicular to the x-axis. And if my sliver goes perpendicular to the x-axis, what is my thickness of that sliver going to be? Could you also memorize on the forever card for volumes by cross sections that v is going to equal the integral from x1 to x2 of an area formula dx whenever you get this wording? Yeah, you can memorize that if you want. But you need to know this idea, and maybe you can just visualize and figure it out. Pause. This is not revolving. Where are the semicircles? What's going on? They're popping up out. Think of a pop-up card. It's just like, whoop, there it is. Okay. So if it's popping up out, here's my semicircle. You give it a little bit of depth. That's where the dx comes in. Okay. There's my semicircular slice. What is the area formula for semicircles?
1/2 pi r squared. But who are if we have d?
Why is Sean saying D?
Because when you subtract top minus bottom.
If you look top minus bottom, that's not going to be a radius of the circle. That's going to be the diameter of the circle. So if the diameter is top minus bottom, or 20 over 1 plus x squared minus 2, what do I need to plug in when I come over here to my area formula? Good. So I'm going to have 1/2 pi, because I'm using my area formula. The 1/2's a constant, the pi is a constant. What are my bounds still? Good, -3 to 3. And I need r squared. But who am I plugging in for r? Could I put this in my calculator as is and not need to stress, and it'll solve it for me nice and neat and pretty? Yeah. That's all you have to write, and then a decimal. Tyler's asking a question, but I need someone to make sure they have solved this already. Tyler, go ahead.
Yeah, it's like 174.268. If you put d over 2 instead, because you're lazy, would they count that? Because you define d just on the left.
That's okay.
there?
Since you defined it.
Where's the minus 2 come? Oh.
Top minus bottom. Because you need to get this measurement, and this measurement at this one little x value will be the y of the top minus the y of the bottom. Those two subtracted will get you this length. It's not a formula, it's more of an understanding. Because, for instance, if we were popping up in squares instead of semicircles, I would want this whole measurement for base times height, well actually side times side for a square. So for a square, it would just be top minus bottom squared, side squared. For a rectangle, it'd be top minus bottom, the base, times whatever height they give you, because they have to give you some sort of clue. Like in the one we did in class, the height was 1, I think. So you would need the whole top minus bottom. If it was an equilateral triangle, you would want the entire side top minus bottom, only for semicircles. Cross-sectional slice semicircles. The top minus the bottom needs to be cut in half, because a circle wants a radius. Yeah. It's only semicircles. The rest of them pretty much top minus bottom. Or if it was perpendicular to the y-axis, right minus left. I don't want to tell you guys it's always top minus bottom. It depends. But there we go. Kiddos, have we reviewed the area formulas? Top minus bottom, right minus left. Oh, double check. Sorry. Tyler said 174.268. Now, if you guys if you're putting this in your calculator, I just encourage you real quick. Okay. There isn't the alpha shortcut that gets you to the integral pretty fast. Number 4, you can also do math and go down to function. Either way, you can integrate whether it's in the math or the little shortcut. When you go to plug in, do you guys realize how the calculator function is kind of just set up to have you forget the 1/2 and the pi? Because that just pops up and you just don't even think about putting it in front. It's not a big deal as long as when you do that, you say, wait, oh, times 1/2 pi, that's okay. When you go to plug into your integral, can I please encourage you to use the nice fraction button? Because if you use the nice fraction shortcut, you can make this exactly what you need it to be. And even up here, can't you put another fraction button? Now, you could have also put a little y1 right there, because you actually have it stored in y1 and not. But if you want to, like, no, I want to see everything. I want to make sure I'm doing it perfectly. That's totally fine. But please use the fraction button. Because if you were doing this, just like with division signs, there are so many mistakes you could make with your parentheses that you would need to put in for grouping symbols. But now that I have this all put in and it was divided by 2, ooh, but wait, some of you guys get stuck. I need to do a squared, and the notation is stopping me. So what am I going to do? I'm going to put a parenthesis with a squared. I'm going to go back and say, oh, I should have closed in this whole guy with a parenthesis. So I'd have to go back. Sean, you were saying something. Even though the 1/2 pi, if I forget it, can I put it back in there at the beginning?
Yeah, totally.
How?
Well, you can use a parenthesis right here. And then before it, you can insert your 1/2 pi.
Ooh, insert. Some of you guys actually don't realize that if you forgot to type something in and you want to put it in later, delete. insert whatever it is that you want, like 1/2 times pi, without having to read everything all over again. That's pretty spiffy, right? The only thing I'm missing now is, sadly, I never put the... So here we go. Never mind. You guys already solved it.
I just click enter, and then it says error,
And then you just go fix it. That's not a bad idea. But, I mean, your calculator goes a lot faster than my poor little laggy one up here. So we've all collaborated. We're good? All right. Kiddos, the test review that you guys had last night. Let me get rid of that. We don't need that necessarily.
I'm a little spooked about this data.
Practice multiple choice we haven't done quite yet.
I don't know. This is kind of hard.
I think I have the test review actually written down somewhere. Let me see if I have it written down. Ideally, I do. Nope, I don't. Okay. So with the test review that you guys had, let me go ahead and get a slide real quick because it makes everything nice and neat and organized. Okay, I'm looking for questions on the test review if you guys have any. So, chapter 6, test review. Oops, if I can spell right, struggle. All right, what questions do we have? Are we okay? 15B, is that on the first page? Is that 448?
No, it's the second page.
450, 51, yeah. So 15B, okay. I'm going to go ahead and write that information up so we can look at it. You guys can be looking at yours. P.S. If you're bored, what could you be working on right now? Studying the forever cards or playing with the multiple choice that's in front of you, yeah? Or playing with the multiple choice that's in front of you. P.S. Look at the multiple choice. What's on the bottom upside down? Oh, okay. I mean, you should probably ignore them so that you don't just jump to the right answer, but the answers are right below upside down, just saying. Okay, coming back. That's just for those who are bored. Page 450, or you guys know it's the 450 section, 15B. Okay. I'm still listening, though. Are there any other questions that we have? Say it out if there is. Okay. This is for the region R. Then we have the region S, which is bounded by. What do you guys think? Is it helpful to get a graph? Okay. Letter B says R about the y-axis. About the y-axis or x-axis?
About the y.
Just real quick, since, I mean, I'll finish going through it because maybe someone else had a question on it. Since it just says R, I'm going to ignore S because it's not involved in letter B. So just looking at R, that's an x cubed, right? Okay. Just looking at R. I have x cubed, something like. I have y equals 8, which would probably be a lot higher, but that's okay. Something like we have y equals 8. We have y equals x cubed. And the y-axis. If you guys are needing to find your regions, you need to write all three things that they tell you, including the axes, and then say what is closed in between. There we go. That's what's closed in between. That's R. So then that R needs to be rotated about the y-axis, which is really nice in some ways, because in some ways, isn't that flush against the y-axis? That's flush against the y-axis. Why am I saying that? What are we going to use? Washer method. Good try. Washer method, our whole would be 0, so it wouldn't really make a big difference. Our little r would be non-existent. So disk method, because it's flush against, as Nathan, you already mentioned this, right? It's going to be dy. It's about a vertical axis. This is the one formula that we haven't really practiced yet today, the disk method. But the disk method says, no big deal. Start at the axis, just like with washers, and then extend outward. There it is. It goes right. You say, hey, there's no hollow. All right, cool. So when I go to plug in, I'm just going to have v equals pi times the integral. Uh-oh. We'll get back to our bounds in a second. But the r is just going to be right minus left. Now, what's the struggle with right minus left if I need to be doing right minus left with a dy? Can I write x cubed? Since I can't write x cubed, what am I going to have to do to this function? I need to go ahead and solve for x. It'd be the cubed root of y. And how do I know that? Because dy is what it needs to be in terms of. So then my right will be the cubed root of y. X equals cubed root of y. My left will be x equals 0, which is the y-axis, just minus 0. What's the one thing I'm missing? I have my pi r squared. There's no hollows, so no little r. That needs to be squared also. What am I missing? Okay. So bounds. Do I need to find this intersection point? Yeah. The intersection point would be, well, wait a minute, 8 equals x cubed. Wouldn't that be at x equals 2? Isn't that the point 2, 8? So what are my bounds? No. Can't be 0 to 2 because it's dy. So instead of going from x to x, I need to go from y to y. 0 to 8. I need y1 to y2. 0 to 8. Remember, you have to switch your orientation, switch how you think. Instead of going from x to x, you need to go from y to y. Plug and chug, you're done. All right. No, it doesn't have to be a calculator problem. Because in order to solve it, it'd be pretty basic in the sense of
solving that, yeah, because you have y to the 1/3, but then
2/3.
Oh yeah, and then 5/3, and then 3/5.
But remember, if this is a long answer, you don't have to make it pretty, right? You just plug in and leave it. But the cubed root of 8 is actually really nice. So if it was a multiple choice, it wouldn't be too nasty either. I'm just going to pull the 3/5 out because who wants to deal with that twice? And then I have 8 to the 5/3 minus 0 to the 5/3. Our brain does not like 5/3, right? The 5/3 power. But if you were to write it in what it actually means, 8 to the 5th cube rooted, then we can say, wait a minute, don't we know the cube root of 8?
Oh.
Isn't the cube root of 8 just 2? And then I just need it to the 5th power. Then 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and 32 times 3 is going to be 96 pi over 5. I believe. I did that kind of fast. 4 and 4 is 16, 16 and 2 is 32, 32 and 3 is 96. Yeah, 96 pi over 5. Definitely could have been a multiple choice by hand. All right, cool. You guys are working on the practice test. Let me go ahead and draw your attention somewhere. Some of you guys are wondering a few things. Number one, the practice test, it has multiple choice, but look on the very, very back page. Does it have anything else? Sorry, I got rid of it. It has one page of multiple choice. P.S. A calculator may be used for this page, right? So you can use the calculator to solve your integrals. You don't have to do them by hand. That's why some of these are decimals. Some of them aren't, but you could go ahead and match it up. Do you see how some of the multiple choice questions want you to go all the way, and some of them are just like, hey, can you set this up? Do you see the difference? Some, can you just set it up? So just keep an eye on the multiple choice. If you're on the test tomorrow and these are all the answers, you don't have to solve. Don't waste time. But if they're actual numeric answers, well, you'd have to go all the way. Then you have another page of more multiple choice. Now, these all, I think, are being solved for. A lot of them. So this is just an example of, hey, what if you couldn't use your calculator? Why am I going to encourage you to not use a calculator on these ones tonight or this afternoon or right now? Because you can't use a calculator to get a graph either. So something you need to think about, could I deal with this if I can't get a graph in my calculator? Can I use my basic graph knowledge to figure it out? Can I use my natural bounds, finding the intersections to figure it out? And then, oh, hey, what do you see? My work. So not only do you have the answers, but my work is online. Sound good?
For these multiple choice?
Mm-hmm. Now, what's on the very back page?
All of the answers?
I think there's an FRQ hiding back there somewhere, isn't there?
Yeah, just yeah, why?
Do any of them look familiar? They don't look familiar in that they're ones that we've done, but they do look familiar in that I think we saw some of the pictures a second ago when I was scrolling through. Like, ooh, that's one, yeah?
So wait, can that one?
Is that another one? Okay, So here's, there's even another one? There's even another one? I want you guys to, hold on. I don't think you guys have this one, do you? Hold on, help out real quick. Is this the same question as your number 6? If so, we need to cross it out. Is this your number 6? Let R be the region in the first quadrant. It's not, right? Okay, this is from another assignment. Some years I give 2 assignments leading up to the test. This year for you guys, I only gave 1. We just did a lot of examples together, so just ignore that page. I'm going to go ahead and put the answers to the FRQs. I'll put the answers online too. So if you guys notice, that way you don't have to go looking in the notes or anything. Right now I have Chapter 6, Practice Test MC with key. That's what you just saw, the multiple choice questions with my work at the end. And then I'm also going to load the Chapter 6, Practice Test FRQ key. Does that make sense? So if you guys want to use it to practice, you can. The practice test will be due tomorrow. The practice test will be due tomorrow, but it's up to you as to how much time you spend on it. Does that make sense? The test review is in your homework file that was due today. The practice test is the handout I gave you. So it's due tomorrow, but do you realize how there's going to be solutions everywhere? So it's up to you as to how much time you spend on it, but it does need to be fully attempted by tomorrow. My advice would be attempt it, then grade it, but that's my advice. Okay. I'm cool letting you guys... Do you want to do a vote real fast? Do you want me just to print out little half-sheet quizzes that you take quick before the test tomorrow, or do you want to get out of the way today? How many of you guys just want to get out of the way? Grab out a half sheet of paper. It was the majority, so we'll just grab out a half sheet of paper. Yeah. You can pull the pie out. Just make sure you put a parenthesis around the r squared minus r squared.
Yeah, just put it in the whole thing, David. You're gonna forget your pie.
I mean, that's just true. I don't like doing it. It just adds too much.
Look, David, I know you think you're never gonna forget your pie, David, but you're gonna forget.
I'm not gonna forget her. She's unforgettable.
I hope you don't. I hope you don't.
I think yesterday it made me not want to bring her. You heard this?
You know, David, I still have like several coupons that Doc gave us for the wing stop place. David, you're a real